y prime. Okay? 0, 1, 2, 3, 4, 5, 6. So at time 0, I'm taking the convolution of u and x prime, right? So perfectly right now. So we have 1/2 times 0 is 0. 1 times 1 is 1, right? 1 times 1/2 is 0. I mean 0 times 1/2 is 0. So you have 1. At time 1, we shift this to here. So you have 1 times 1/2 is 1/2. 1 times 0 is 0. 1/2 times 2 is 1. So that's 3/2. What about the time 2? You have 1/2 times 0 is 0. 1 times 2 is 2. 1/2 times 0 is 0. So that's 2. And so on. So this function works. Okay? So the one I gave you doesn't work. Let's erase it. Okay? Good. That's good. It's still a low pass filter, but we have to see that it's 1/2, 1 and 1/2. After we do all of this, you will see that it preserves the value at 0, 2, 4, and 6. And I interpolate, take average of the other sample. Will be like this. Okay, let me pause for questions.
Actually, there's another question. A little bit difficult, the one I'd like to see. So maybe can you draw a line?
Okay.
About 2/3 of the board.
2/3 of the board.
To remind you that it would never
go down.
Below that.
Okay. All right. Good. Okay. So we discuss that later on. Okay. Let's stay with 2 right now. Other question?
Can we use the odd value upsampling?
Odd value 3? Yeah, we can. Okay. Let's save that for later on. And the other question regarding this. So let me summarize everything, okay? I will erase everything and summarize what's going on. Involve first upsampling, okay? We first upsampling by 2 for now. We can have L later on, okay? And then design a filter H. So this is Y of N, U, which is X. And we show that this filter has to be designed carefully, otherwise it doesn't work, right? So one example we have is this filter. We have, we use over here. This is H, okay? One of the examples we have is H is 1 at time 0, 1/2 at -1, and 1/2 is 1. This one works, right? And this gives you a linear interpolation. Okay? How do I make it smoother? I need to change this filter. I need to make it maybe longer. Okay? So how do I increase the support of this filter? Not from -1 to 1, but maybe longer. We have more, like you can put 0 sample here, but it doesn't do anything. So if you add more sample, right? So you add a sample here and a sample there. It turns out that the next sample has to be 0, and then this can be something else. Okay? This is called half band condition. So this filter is called half band filter. And this is a very important filter in wavelet and filter bank. You see it all over, repeated, okay, everywhere. The filter that is 1 at time 0 and 0 every even sample. So how do I write this? H of n equal to, what will be a shorthand notation for this? How about I say 2n equal to delta n? Would that work? You know delta n, right? Would that be okay? At time n equal to 0, x of 0 is 1. When n equal to 1, x of 2 is, what is delta of 1? 0. When n is minus 1, x of minus 2 is 0, and so on. That's the shorthand notation to describe a filter where every even index except 0 becomes 0. Okay, so minus 4 is 0, and so on. Minus 1, 4. Any question regarding this definition of half-band filters? You can show that this filter, if you use it in interpolation, it will preserve the original sample. Okay, so this one, preserve the original sample. Before, right, we have 1, 2, 1, minus 1. That's my signal, right? 1, remember? You have signal of 1, 2, 1, minus 1. These filters, the output of these filters will have exactly this value. Okay? 1, 2 at 2, 1 at 4, and minus 1 at 6. And depending on the value that you have here, 1/2, 1/4, and so on and so forth, the non-zero sample, you can have either a linear interpolation or qubit or whatever you want to design it for. Right? So that's the property. Okay, so let me pause for questions. So if you go to MATLAB or any, Photoshop, anything that they use for interpolation, the filter is like that for scaling by 2. Okay, right? So you can go home and you can try it out. Use another filter, and it's not a half-band filter, and you see that this value here will not be preserved. It will change the value. It has to be 1 at time 0, and 0 at 2 minus 2, 0 at 4 minus 4, and so on and so forth. Okay? And then we will interpolate. Is that clear? So I'm going to discuss this in terms of frequency domain now. Okay? If I have x of e to the j omega, that's the Fourier transform for x. What does u look like? What is u of e to the j omega equal to? Is it related to x? It has to be, right? Okay, and the x of company. Q omega. Well, let's verify it, okay? What is x of e to the j omega equal to? 1 plus 2 e to the minus j omega plus 1 e to the minus j2 omega